So you should know the definition of the U and the definition of the mole. Okay, and then if you know the definition of the U and the definition of the mole, then this is easy to derive. But this is also easy to remember. I don't know why they do it this. If you look in most books, they do it this way. They do it this way. 1 gram is equivalent to how many U? Not moles of U, sorry. Most books do it like this. They do 1 U is equivalent to 1.66 times 10 to the minus 24 grams, which is a hard number to remember. I don't like that version. 1 U is equal to 1.66 times 10 to the minus 24 grams. 1.66 times 10 to the minus 24 grams. They also have it in kilograms as well. But either way, it's easier to remember using Avogadro's number. Avogadro's number is a very common thing to memorize in chemistry. Now let's continue with this. Okay, so the first type of conversion we can do is by using Avogadro's number. That is, we can go from moles to units, or units to moles. And so we can go from number of units to moles, or moles units. The conversion factor that we're going to use here, number of units to moles, is that we know 1 mole has 6.022 times 10 to the 23rd units. And then, or 6.022 times 10 to the 23rd units is equivalent to 1 mole of units. 1 mole of units. All right, so if we had 0.25, quarter mole of ammonia, how many ammonia molecules is this? So let's do this example here. What is the formula for ammonia? NH3. So this is just one we have to memorize, NH3. And what do we have? 0.25 moles of NH3 molecules. How many molecules is that? Well, I know that there's 6.022 times 10 to the 23rd molecules per mole of molecules. It's like you would know that 12 dozen eggs per, I mean not 12 dozen, that you'd know that there are 12 eggs in 1 dozen eggs. That's what I'm saying. So we would have 6.022 times 10 to the 23rd eggs per 1 mole of eggs. All right, so it's going to be 1/4 of that. Let's see what that comes out to. Actually, here I have to calculate it. The book has already calculated it. Just dimensional analysis, except the book used this. They used it to 3 sig figs. So I'd like to go to 4 sig figs here. Let's see what the book did. Book didn't properly round the answer. How many sig figs are we allowed in the answer? They have 4 sig figs here in the answer, but are we allowed 4 sig figs? How many sig figs are we allowed? Just 2. They didn't bother. So I'm going to calculate this myself. 0.25, and then I have an extra digit on Avogadro's number. times 6.022 times 10 to the 23rd. 1.50. 1.50. So we're only allowed two figures. 1.5055 is 10 to the 23rd ammonia molecules. Well, ammonia is going to form molecules because it's one, it's binary molecular compound, but it's also composed entirely of molecules, and we don't see any common ions there that we're familiar with. And so you pretty much get the same answer. 1.5 times 10 to the 23rd ammonia molecules. All right, so we call these, we have all different kinds of names. Let's talk about molar mass, atomic mass, molecular mass, formula mass, all those. Molar mass is going to be quite important. So if I go back to water, we'll have something called the molecular mass. And the molecular mass is 18.02, so U. Therefore, we have 18.02 U per molecule of water. How much we'll call it the molecular mass. We could also call this the formula mass. The formula mass is just a generic term. Whatever the formula is, that's its mass. So this is the formula, this is its mass. Formula mass as well. So the formula mass is equal to the molecular mass, which is equal to 18.02 U per water molecule. Now, if I had a mole of water molecules, then we generate something called the molar mass. The molar mass is different. Molar mass is going to be 18.02 grams for that. Therefore, we have 18.02 grams of water for every mole of water molecules. So, per mole of molecules. Interestingly, formula mass is used for everything, including the molar mass. Because numerically they're the same thing. So somebody could be talking about the formula mass and also be talking about molar mass. However, these are not equal. Molecular mass and molar mass are different.